Okay, B3. Use integration by parts to calculate this. And I can see from the question that I'll need to use integration by parts twice. Integrate 0 to 1, x squared ex dx. So we have f equals x squared, f derivative equals 2x, g derivative equals ex, and g equals ex. So this becomes, I'm going to leave the limits for the moment, f g minus f derivative g. And then this needs integration by parts again. F equals x, f derivative equals 1, g derivative equals ex, g equals ex. So this equals, well, I can't resist, I'll put the brackets in, 0, 1. Okay, so this is x squared ex minus 2 bracket f g minus f derivative, which is 1g. This equals x squared ex minus 2x ex. Now, the integration of ex is just ex, so that's actually gone, that integration. It'll be minus and minus is plus. Okay, nothing I can simplify there. So I'll just put in my numbers 1 and 0. If I put in 1, I'll get e minus 2e plus e. And if I put in 0, I'll get 0, 0, and 1. So, will that just be 1? Minus 1? I feel bad. Yeah, I lost an E somewhere. Let's watch carefully. F derivative, g derivative, fg minus f derivative g, f derivative. Looks okay.
The very last thing should be 2
Oh, I forgot the 2 multiplying that, thank you. So there should be a 2 here. So that changes this to a 2 and changes this to a 2. Okay, that's much better. So 2e minus 2e is gone and you're left with e minus 2, which is correct. Okay. B part 1 is they want you to express this rational function in the form a plus b over x minus 1 plus c over x minus 2. I can tell straight away that this has factors of x minus 1 and x minus 2, so I'll just write them in instead. You can just copy it again if you want. So x minus 1, x minus 2. I multiply everything by this denominator and I'll get 3x squared minus 3x minus 2 equals a, x minus 1, x minus 2, plus b, x minus 2, plus c, x minus 1. Let x equal 1. So then we'll get minus 2 equals minus b. So b equals 2. That's my first answer. Okay, next, let x equal 1. let x equals 2. 2 squared is 4 times 3 is 12. 12 minus 6 is 6. Minus 2 is 4. That's gone, and then 2 minus 1 is 1, so c equals 4. And lastly, let x equal 0, and then use my answers b and c. So I get minus 2 equals a times minus 1 times minus 2, so that's 2a. Minus 2 times b, which is minus 4, and then 4 minus 1 is 3, minus 1 times c, which is minus 4. So that's minus 8. Take it to the left is positive 8. 8 minus 2 is 6, divided by 2 is 3. So I get a equals 3. So the answer is, it equals 3 plus 2 over x minus 1 plus 4 over x minus 2. Let's check that. 42. Oh no, that's 2 marks. B is 2, C is 4, and where's A? Where's A? Say again?
You can go to the bottom.
Oh, I can see it here as well. Okay. So the next part is they want you to integrate this function now. Integrate from 3 to 4. 3 plus 2 over x minus 1 plus 4 over x minus 2 dx. That equals 3x plus 2 log x minus 1 plus 4 log x minus 2. Yeah, 3, 4. Well, this is kind of easy for 6 marks. Now I put in 4 and 3. So if I put in 4, I'll get 12 plus 2 log 3 plus 4 log 2. And then if I put in 3, I get 9 plus 2 log 2 plus 4 log 1. Well, that one's gone. 12 minus 9 is 3. 2 log 3, oh no, they can't go. I can bring the square up the top and the 4 up the top and the square up the top. Oh, I can add those together, can't I? I can't do anything with this one. Plus 2 log 3. 4 log 2 minus 2 log 2 is 2 log 2. So that would be 3 plus log 9 plus log 4. And then when you add logs together, you can multiply their arguments. So that would be 3 plus log 36. The reason I simplified it to this stage is they usually ask you to simplify your answer down. They didn't this year, but most of the time they do.
Do we need to give an answer as a decimal?
Well, let's do that as well. But rather, what I'm going to do is check the answer on the calculator. So this is coming out as 6.58. Now if I can type the integration in on the calculator, I have from 3 to 4 fraction 3x squared minus 3x minus 2 over x squared minus 3x plus 2, and calculator says 6.58. So if this was the exam, although I don't have the marking scheme, I can know I got 6 out of 6 for this, which is nice. And then that's the end of that question.